Okay, welcome back to the Dublin Academy of Maths. Now today is a new series. It's series 8, and we're dealing with episode 1, and it's length, area, and volume. Okay, so there's not going to be that many episodes in this one. This will be 3 actually. So this is going to be quite large videos as such. Now excuse me, today I'm short of breath. I have a cold, head cold. Actually allergies, I think it is. Anyway, area is equal to length by breadth. Length by breadth is area. Okay, now it's always expressed, area is always expressed in units squared. Okay, so if you have whatever units you're using, you unit in units squared. It was the same for in coordinate geometry of the line. You know, once you get an area of something, or the circle or whatever, you get an area of something, you put in units squared, whatever units you're dealing with. Area of a triangle is half the base by the perpendicular height. Okay, so you have to find the perpendicular height. If you're not given it, they might give you it out here or something. But remember, it's always dealing with the perpendicular height, especially parallelograms and triangle. Now the difference between the parallelogram and the triangle is you can remove the half. So it's the base, the length of the base by the length or the height. Okay, length is usually referred to as this twinned with height. So every area is taking out the half, so it's two triangles in here. If you look at it, you'll find the perimeter length twice h plus b, that should be, okay? Twice h plus b. H is the perpendicular height, remember. Now we're dealing with a circle. Now the circle is very interesting as such because they've come up with an area of the area is equal to pi r squared, referring to a circle. Now pi is equal to 22 over 7. You may ask yourself, what is that? That is a ratio. Okay, so a perfect circle. Well, every circle is a perfect circle. Every circle has a ratio of its circumference to its radius of 22 is to 7. Okay, 22 is to 7, right? That's their ratio. Wasn't it fantastic? So now they could solve a lot of things using that now. So pi is either 22 over 7, and when you divide 22 by 7 you get 3.14, and it goes on for a long time. And lots of people might try and make records to find out how many they can remember. Okay, the memory games. So that's where that comes from. Now the length of it is just 2 pi r. So it's 2 times 22 over 7 multiplied by r. Now if they ask you in terms of pi, okay, it means that you just don't change pi, everything becomes simplified, okay, because you're not dealing with decimals or fractions, okay. But when you're we'll get to questions anyway. So that is area and length. Now remember, lengths are just respected in units, and area is respected in units squared, okay. Right. And now we're going to move on to Simpson's rule. We'll just, first of all, I'll just take out this and I'll show you something, a sector. Now, a sector hasn't come up in a while, but that doesn't mean it's never going to come up. Okay, now a sector is something of a circle. Okay, you see there, that's a remnants or a part taken out of a pie as such. You know, the circle goes around. So you have to find the area of that, or the length of it. Okay, so now you see that theta here. Theta is the angle in terms of pi. Okay, so if theta is 60 degrees, it's 60 over 360. Okay, so it's 6 over 360, which is 1 over 6. Okay, so that sector is a 1/6 of a whole circle. So by finding that, you can find that the area of a circle is equal to the angle 360 times whatever you're looking for, the area or the length. For example, the length is 2 pi r, or the area. You know, once you know that the angle must be, it's a part of a circle, so you must represent it as a fraction of a circle. Okay, and you would figure that out. Okay, so that's the angle over 360, and if it was 60 degrees, it becomes 1/6 times 22 over 7, and the radius will be, say, was 6, so that'd be 6 squared. 6 cancels with the 6, you're left with 6 here because they're 6 by 6, okay. Right, so that's how you deal with sectors. Now they're important, might come up, just remember it's a fraction of a circle. Okay. Right now, I'm going to move on now to Simpson's rule. Simpson's rule is not a difficult rule to remember. The only problem is that errors can occur. Right now, as you may or may not know, that Simpson's rule is used a lot in calculating now, areas of fields or whatever. But remember that on page 7 you have volume, and you have on page 6 you have area. Okay, so log tables or mathematical tables. That's out of the way. Now we're going to deal with this Simpson's rule. So, for example, I'm sure you have done a few of these anyway, but we have a piece of land. Well, I'll read out the question in a minute. And it's got 1, 2, 3, 4, 5, 6. Okay, so it's got 7 jumps. 3, 4, 5, 6. Right. Now they're evenly spaced. They're supposed to be evenly spaced. Right, now this is rough, so don't think I have everything perfect here, because I don't. They're not evenly spaced. Well, they look it, but they're not. 1, 2, 3, 4, 5, 6. Right, one too many. Right, so we've got measurements here. This is 9, 10. These are all in meters. 9, 8, 7 meters, 5 meters, and 4 meters. Okay, now you're given this and you're told the spatial difference between those is 3. Now it's all measurements in meters, all in meters. Okay, now it's telling you the width of that. The width of that is 3 meters. Okay, not the whole base length. Now it shows a garden that's built. Now this is question 12, 2012, paper 2, and it's one of the sample papers. And it says the sketch shows the garden of a house. Okay, at equal intervals of 3 meters along one side, perpendicular measurements are made to the boundary as shown on the sketch. And it says use Simpson's rule to estimate the area of the garden. Okay, so Simpson's rule is W, the width, over 3. The first reading, you take the first reading plus the last reading, and you take plus twice the odds, the sum of the odds. That means sum is adding twice the sum of the odds, last plus twice the sum of the odds, plus 4 times the evens. Okay, the sum of the evens. Okay, so you have to work out in the brackets first, as you see, brackets here and brackets here. Now the next thing I'm going to do is I'm going to label it. Okay, so I label this. I know my measurement is 3, and I go along and I label it, starting with the first one is odd, even, odd, even, odd. This is the first reading and this is the last reading, so they're not included. Okay, so what's the width? The width we said was 3 meters. Okay, so the width here was 3 meters, which we rubbed out. So it's 3 over 3. That's nice and handy already. That's 1. Plus the first reading, which is 9 meters. You can see that the length is 9 meters. Plus the last reading. The last reading is 4 meters, as you can see. Plus twice the odds, the sum of the odds. Well, the odds is, we look at the odd numbers, 9 and 7. 9 plus 7 plus 4 times the evens, so we're looking at 10 plus 8 plus 5. Okay, and we do what's in the brackets first, so that becomes 1, so that's 1 times 9 plus 4 is 13. Well, I'm just doing this so as I can. So I got 9, 7 is 16, 2 16s are 32, plus 10 plus 8, 18, 23, 4 23s are 102. 92. There you go. And you get out an answer, 137, and it's in meters, so it's meters squared. Remember the square, because you don't, you lose points. So that's how you find the area of an irregular piece of land. Okay, now you will get some questions here, and they might give you 4 and 5, 4 and 6, like so. They'd give you this type of thing. They draw the base along there and then they split the measurements up. Well, you do the same again, but you're just adding them. Okay, so I'm splitting them up to show you what they might be like, even though they're irregular. 4, 3, 4, and then you might have 4 and 1 here. Okay, for the 5. So they all add up the same, but you must use the same process again. Okay, so that's when they split the irregular piece of land. Okay, so that's the only thing that can confuse you, right? That's good. Moving on. Now, okay, so there was a next part of that question, and it says there was a pond. The owner of the house digs an ornamental pond in the garden. The surface area of the pond is 7 meters squared. Surface area of the pond is 7 meters squared. What percentage of the area of the garden is taken up by the pond? Okay, that should be okay. So that's the pond, and the whole area is 137 meters squared. Is the whole garden area. So he builds this little ornamental pond and give your answer correct to the nearest percent. Okay, so well, you know, I have to find. So this is 100%. Let's look at this as a percentage, so as you know what's happening. This is 137 is 100%. So if it takes up 7 meters, so we have to find out what 7 meters is of 137. So we just, we multiply. Okay, so we're getting 7 meters of 137. To find its decimal, we multiply by 100 over 1. Okay, we're not given anything. We're just given what we're given. We are to find the fraction of this, and we'll give it as a percentage form. Okay, and that's essentially what you're doing. You just find it is given in a fraction. There's no manipulating the formula, and you're left. That's 5.1. Okay, so rounded off to a percentage, it's 5%. Okay, so you see that. Okay, we did this before in percentages in the previous. It was episode in paper 1, episode 6 or 7, series 6 or series 7. I can't remember. I must look it up. So there you go, that's the percentage that he builds this pond, and that's his percentage of occupies the area of the garden. Right, moving on. So really that's everything explained now. You know, I could just go along to the question. I'm going to think this is nice and handy. Remember that you just take your time doing these questions. That's all, because they don't seem to be they're not that difficult for me. I like these type of questions anyway. So the question is 2012 is a sample paper question, and this is the area of a rectangular football pitch our field is 9,900. The width is 90. Find the length of the field. 2. Find the perimeter of the field. The perimeter of the field is when it goes right around. Okay, now, so really the area of this is 9,900. Okay, and you're told that the width is 90, and you know that 90 by the length or the breadth, the length is going to be equal to that. So manipulate the formula. 90 times L is equal to 9,900. I'm doing this question for you. L is equal to, okay, is manipulating the formula, series 1. The sketch shows a lake bounded on, so remember, always draw out your diagram. I forgot to mention that, always draw diagrams. The sketch shows a lake bounded on one side by a straight dam. Bounded by a dam. Okay, now it's all in meters, so you got 80 meters here, you got 10, 25, 30, 38, 36, 22. Use Simpson's rule to estimate the area of the lake. Okay, area, meters per meters squared. Alright, this seems to be okay. Right, I'll leave you with that. Thank you. I hope you do all those questions. Now remember, in my program, because you're the first to see it, is you do plenty of questions. Questions. You do 70%, or you make your mind up and you're going to say I'm going to do at least 70 or 80% of these questions that Michael hands out to me, you will get a B. I guarantee you that, you know. And if you have problems, you can get back to me on it, you know, through my webpage and through my email. My email is dublinacademy@gmail.com. Dublinacademy@gmail.com. Michael Dalton. Okay, thank you.